All right, guys, here we are back again with part 2 of getting started with electricity. A few things you want to know about circuits. All right, so here are some things you want to keep in mind. The following right here basically is showing that you need to have a complete path from the energy source or the power, okay, to the point of least energy, the ground, okay? So it needs to be a complete path to travel. That's something you want to keep in mind here, okay? And so it flows like this from here, 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 and then down. It follows right in order, okay? Something you need to also realize is that all the energy does get used up in a circuit by each of the components in it. So in this case, like the LEDs and the wires, okay? And each of those components converts some of the energy into another form of energy, okay? So for example, this circuit is using a 9-volt battery to do that, okay? So the flow of current at a specific point in a current will always be the same, okay? Coming in and out, just like it says here. It's always going to be going like this, coming from the source, going down this wire to the components and out ground, okay? Remember, highest potential, lowest potential. It always is going to flow that way. All right, always going to seek the path of least resistance, okay? So keep that in mind. You want to make sure that, so for example, you don't want to have a short circuit. Short circuits happen because the power source and the wires convert the electrical energy, right, to heat, which is normal. And usually sparks can cause an explosion. So if you've ever shorted out a battery and seen sparks, you know exactly why that is because there's no resistance, okay? That's why we have a resistor here. If we don't have a resistor here, it explodes, okay, or makes a fire or sparks or something like that, okay? Next thing, what's a breadboard? Right here, you're going to see an example of a breadboard. You have the 5 holes in each horizontal row are connected electrically through metal strips on the breadboard, okay? These 5 holes right here. The vertical strips run the length of the breadboard. They are electrically connected. The strips are usually used for power and ground connections, okay? And the middle row breaks the connection between the two sides of the board, okay? So that means that this allows this side and this side not to be connected, okay? But that is basically what you're going to use. And it's a way of creating circuits without having to solder. That's basically what it is. If you remember when we did soldering to do our underwater robots, we're not going to do that here because we're going to use a breadboard, and that's going to allow us to create circuits without soldering, which is really kind of cool. Okay. So we have some different components here that you're going to want to go ahead and review. I'm not going to go through them all. You can certainly do that yourself. Keep in mind, an LED is a light emitting diode. It converts electrical energy into light, okay? There is a longer side and there is a shorter side, or sometimes you'll find, let me see if I can get you'll find that there's a little notch in it, okay? If it's either the longer side or the notch side, this is going to be the positive side, okay? And the shorter side is going to be the cathode. In the slides that I made for you, you'll see that I give you 2 different examples, okay? All right, so again, resistors. If we have a resistor, we can control the amount of light that goes in or the amount of energy that goes into the bulb. If we don't have one, it can burn it out, okay? The starburst that you'll see here is going to show you that, you have way too much current going in here. You need a resistor, it's too much, okay? All right, so push buttons, okay? This is just showing you here that there are 2 pins of a switch that are connected to each other. Here's the switch. This is what it looks like when it's open. This is what it looks like when it's closed. All right, it's kind of a schematic view. That's the button right here that we press. Okay, and I think we did it. All right, thank you guys.